And welcome to the Industry 4.0 Community Podcast. I am your host with the most, Walker D. Reynolds. Our guest today is Matt Trifiro. Who is the Chief Marketing Officer at Vapor.io. Is it Vapor.io or Vapor.io?
It's Vapor.io, yeah.
All right. So what we're going to do is we're just going to continue the conversation we were having in pre-production. And so for the audience who's listening, we're going to have a conversation centered around AI and ML. We're just going to kind of go wherever. I was on Matt's podcast, the On the Edge podcast. If you don't listen to it, you should. It's one of the few podcasts in our industry I actually listen to in its entirety, actually. I listen to most, but I listen to your podcast in its entirety, Matt. And but we were just having this conversation. Matt was saying, Matt and Zach were
talking about our kids.
Yeah, talking about children and artificial intelligence and education. And Matt, what were you saying?
Yeah, so I was saying, I have this kind of frictionful relationship from school as a child growing up, which is like, it was boring. The homework seemed unimportant compared to things I was interested in. I didn't really understand it. My parents forced me to do all this stuff, and I see the same thing in my kids, see the same friction. And so I have had this thought recently, like the last couple of days, where I give my kids a choice. I'll pull you out of school. I'll homeschool you. And your job will be to teach yourself everything about AI. And I'll create the curriculum. Like, I'll tell you which videos to watch. Like Peter Abeel's greatest hits, Jeff Dean's greatest hits, right? Andrew Ng's greatest hits, Walker Reynolds' greatest hits. Right. And you'll come out, I think, with a better education than your peers.
And what I was saying was, my kids are all older. So I have, my youngest kid is 16. His name is Hayden. He's the most brilliant of all my kids. All my kids are smart kids, but Hayden is super, super gifted. He's been gifted his entire life. I, like Matt, was very bored. Like, school just came very easy to me. I remember when I took my son just took the SAT, and he prepped. It was the hardest he ever prepped for anything, and he took 2 prep exams.
Well, more so, he said it was the first time he had ever really studied for anything.
Yeah, correct. He doesn't, and he's
that was me in high school.
I want to meet him already. I love it.
And his goal is just, he wants 1,400 on the SAT. He scored in the mid, the 2 preps, I think he did 1450 and 1410. When he comes back from taking the SAT, he says, I think I only missed 2 questions, so I feel very. But you want to know why he wanted a 1,400 on the SAT? Because he has no intention of going to college whatsoever. He plans on being hired directly out of high school. Right now, many companies are no longer looking for college graduates. We are one of them. We do not. If you have a college degree, great. Right. But we have actually switched. It used to be a requirement to have a college degree. We don't care anymore. What we care about is aptitude, values, right, and overall intelligence. And Elon Musk has a famous quote saying, it's actually easier for us to just go recruit high school kids who got 1,400 or higher on the SAT, and we'll put them through a 5-year apprenticeship here at SpaceX or at Neuralink or at Tesla or whatever, and they'll get the educate that will buttress the education that they got using Google coming up. That's what they were doing, using Google. Right now, it's AI. I've said young people have access to all of human knowledge at their fingertips. I mean, think about, Matt, you and I are in the same generation, right? And when I tell my kids that I would put together a list.
You had to go to a library and open a book.
I would literally put together a list of things that I was going to look up on Sunday when we went to the public library. Right. We went to the public library on Sundays, our county library.
This is how you dialed a phone.
Right. And I would have a list of things that I would be. I mean, I said I could still tell you the Dewey Decimal System.
Right.
I spent, I wish I could tell you the number of microfiches I've looked at in my entire life. The point is the nature of education has changed, and artificial intelligence. Originally, Google was using really rudimentary algorithms originally, right? And now artificial intelligence has fundamentally changed the game. But I was telling my kids, I was saying to these guys what I told my kids when they were very young, when I was on the school board in our local school district. My youngest son wasn't even in school yet. My middle son was maybe 2nd grade. And I told them, you're not here to learn. Like, you're not going to learn anything in public school. Like, that doesn't mean, and I don't mean that in absolute terms. Right. There are some things you're going to learn, but the bulk of what you're there for is to elevate your peers. Like, you are very, very gifted. And when a teacher has a student like you in the classroom who can answer everything off the top of your head because education is your passion and you're leveraging technology to become more educated, you are making it easier for kids who don't have your resources to get the education they need. That's why you're there. But that isn't what you're not there learning. Like, and the real question, Jeff Rankinen, who's a member of the community, is trying to redefine what post-secondary education is, using tools like artificial.
I think I've learned personally more in the last year than I learned in 4, 5, 6 years of schooling. I can even say maybe even 4, 5, 6 years pre-AI. Because so when I was in freshman college, I took a poetry class, and the teacher left me with this just amazing piece of advice, which is kind of nutty. He said, don't just look up the words, this is paper dictionary, right? Webster's 10th Collegiate. Don't just look up words you don't know. Look up words you do know or you think you know, but might be important. And so I literally carried around a dictionary. And every time I'd come across a word that met that criteria, I'd look it up and I'd write with pencil. I'd write the date that I looked it up next to it. And if I found 3 days, the third time I committed to memory by writing. I was nutty in college. But here's the thing. Now that Perplexity is available, which for anybody who's not using it, go use it. Ask it a question. It'll give you a really good answer 99% of the time. And it will give you sources.
Perplexity is at Amazon?
No, well, Jeff Bezos put some money into it, but it's a separately funded company.
Got it.
Perplexity.ai. And it will give you an answer with citations. So you can actually go fact verify it, go deeper, find all kinds of interesting things. And I've applied this principle. Look up things you don't know, but also look up things you think you know, but might be important. So, you come across something that you're like, well, I kind of know what Open RAN is, but do I really remember how it's different from ORAN? Perplexity. What's the difference between Open RAN and ORAN? Oh, I see. There's 2 articles and there's one subtlety I didn't know. And it took me 30 seconds to just raise my knowledge. And I think that mechanism that we never had before, this like instant feedback loop to explain things. Like you come across a sentence in a textbook and you can ask AI, explain this to me. Well, we never had that.
For those of you who are listening, who your predominant LLM that you're using is ChatGPT, right? Perplexity is the reason that ChatGPT now gives citations in the responses. So because Perplexity was doing that, OpenAI copied them. This is the advantage of competition in the market, by the way. OpenAI copied Perplexity. What I will say is this: Perplexity does a much better job of citing.
And I use them all. I use all of them for different reasons because they're all better at something, and then they one up each other, right?
I got a question.
Yeah.
So obviously you use AI at Vapor.io, and I want to get into that. But like, how are you using, as the CMO? How are you using it day to day besides looking up things that you?
Oh yeah, so I'm probably a little unusual because I'm kind of weird because when I first discovered GPT Playground, which was before ChatGPT, but it was middle last year is when I first discovered it, and I just I was getting things back that I'm like, wow, that took me 5 seconds and I couldn't have done that myself easily. And so I said, I'm going to figure this out. I'm going to treat it like a musical instrument. I'm going to invest at least an hour a day. And I would say some days I spent all day. I'll spend 6 or 7 hours on a Sunday, just learning how to do stuff more efficiently. And I've gotten really good. And the general rule that I've discovered is, garbage in, garbage out, but really, really great detail in, really, really interesting output. So you can ask it a general question, and that's great for just expanding your knowledge. What is 5G, right? What is deep learning? Right? Those are good. But if you're trying to, let's say, convey a complex idea. So so a complex idea might be the difference between supervised learning and
unsupervised.
Well, no, what's it called? Now, of course, I'm
reinforcement.
Deep reinforcement learning. Sorry. Yeah, deep reinforcement. Maybe you'll fix that in post. I'll look smarter. Deep reinforcement learning, right? Which they're both powerful techniques,
right?
But they're fundamentally different and important.
So if I want to fundamentally different, right?
Fundamentally different, yeah. So imagine I know the differences in my head, but I want to convey it to somebody, right? So I can either figure that out myself, or I could use ChatGPT or one of these large language to help me. So the way I would do that is I would say, reinforcement learning is X, and I'd give it, it already knows what it is, but I'll say that I know it, right, to give it some focus. And then I'd say there's a trend moving towards deep reinforcement learning. And the reasons for that are 1, 2, 3. Please write 3 paragraphs expanding upon this idea. And what you'll get back isn't something that I would necessarily use, but it just say, like, I can take those 3 paragraphs and throw out one of them, rewrite 2 of the sentences, maybe rewrite it completely, maybe send it back through the LLM to get something else back out that's closer to what I want. But I do that all the time. And I'll give you an example. So we launched this new product, which is actually, I think, the most interesting thing we've done in the 7 years I've been at Vapor, called Zero Gap AI. And Zero Gap AI is bringing massive GPU compute to the edge of the enterprise. And we can talk about why that's important and all that. But the website, which, it's probably 6 or 7 pages, but there's a lot of information there. I did that in 4 days. And I did that because I used AI. Now, there isn't anything on that that's copied, right? It's original, but I used AI as a co-pilot to put all that together, to clarify things, to, you write something and you send it to ChatGPT and say, rewrite this 5 different ways to make it more easy to understand. And you get 5 choices. Yeah.
How important is it, though? So you're fluent. You have, I would argue, I would describe you as someone in marketing who has very high digital fluency, right? So I'm assuming you have a technical background. Do you have a degree in engineering? Or have you just always
all self-taught?
Right. But you're a self-taught technologist.
Sure.
You're a technologist, right? So that is rare in marketing, number one. So you have the ability to look at 5 outputs from artificial intelligence,
sure,
and pick the best of the 5.
But that's because I put in the hard work to become a domain expert.
Right.
But I'm not a domain expert in, I don't know, radishes.
Right.
But you might be.
But the challenge I see,
yeah,
if you look at, one of the things that we predicted for 2023 would be the explosion of content especially in written form on LinkedIn, Instagram, et cetera. And like, if you go and you look at, say, Unified Namespace or Industry 4, go ahead and just look at the trends on LinkedIn. There's been an explosion in content, vast majority of which, and, I'm speaking for myself here, the vast majority of which is excrement, absolute garbage. It's somebody asking a question, an output from ChatGPT, and they're just literally pasting it in and reformatting, right?
But I don't really think that's that much different than before. It just happens faster.
Correct. It happens faster.
There's always been a lot of really bad information.
So you have lots of, I actually think AI is going to reverse this.
Yeah, maybe.
I think AI, artificial intelligence, is going to increase the quality of communication, not hurt it. Although most people are going to argue it hurts. And here's my point. I use this example all the time. The word cynical. When I ask most people, what is the word cynical, especially if they use it in a sentence, and I go, define cynical for me. Okay. Most people are going to say that it's similar to ironic, but it's the negative version of irony, right? And when the actual definition of cynicism is believing that all people are just motivated by self-interest, that's cynical. Okay, the word when you are a cynic, you are a person.
See, that's one of those words you think but you should look up.
Yeah, you should look up, right? When you are a cynic, you are a person who believes that everyone is motivated by self-interest. When
I'm a cynic.
Yeah. By the way, I'm a cynic as long as you're climbing your first mountain. I argue that, just David Brooks wrote a book called Second Mountain. I talk about it all the time. David's a sociologist who writes for the New York Times. He's right of center kind of guy. He's sort of the very middle. He represents me. He's a very middle, right of center guy. He wrote a book called Second Mountain, says that we all climb 2 mountains in our lives. The first one is when we are taking care of ourselves. It's Maslow's hierarchy of needs. It's all the bottom half of the pyramid is our first mountain, where
we climb down the mountain first, then back up it.
Right. We climb up and down many mountains before we actually climb that first one, right? And then the second mountain is once we've taken care of ourselves. If you have empathy and sympathy and you care about the greater good, that's when you're taking the resources you've generated and you're trying to have a positive impact on other people. And you may not, And you could lose your self-interest in that's climbing that second mountain, right? You don't have to look out for yourself when you're climbing the second mountain, when all your needs are met, right? So I do believe, by the way, I mean, all societies are built on this concept that people look out for their own self-interest. But so I would say I'm not necessarily a pure cynic, but I'm a cynic as long as people are climbing.
I'm close to where you are. There's certainly benevolence, and there's certainly generosity, and there's empathy, and there's all these things. But we tend to act in our own self-interests a lot of the time.
And by the way, there's nothing.
I'm not cynical about that, actually. I think it's actually a healthy thing.
I want to go back to your zero gap AI thing.
Yeah. Okay.
I think it's interesting. So here's what I know about zero gap. So here are the notes. Here are the notes that were given to me. So you guys collaborated with Vapor.io and Supermicro. Is that true?
Well, we are Vapor.io. So Zero Gap AI is a
Vapor.io collaborated
product
with
line. Supermicro and NVIDIA. Yeah.
Right. And so the reason I'm bringing this up is because I want to go to NVIDIA's CEO about what he said about coding. But let's, what is Zero Gap AI? What is the fundamental, the primary focus, the primary value it is supposed to drive for the market? And why did Vapor.io invest in it?
There's 100 different answers to that, but I'm going to try to give you one that your audience might really appreciate. Okay. So let's assume that you want to create a digital factory, right? Right, Walker? We want to do this, right? And let's say we don't want to just use the old technology, machine vision, which in robotics, let's say, that works in a very, very constrained environment. It's got repeatable motions. People go in and they fine tune it. And the same thing happens every time. They encounter no novel situations that they need to solve for. And then we have a new type of AI. There's a whole bunch of jobs that can't be done. Like the final quality assurance can't be done by a robot very well because there's 1,000 novel situations.
Yep.
So in order to roboticize that, you've got to teach the robot to understand novel situations and to learn, right? And that's
to react to permutations.
Because it's mostly going to see things it's never seen before. And the historical way of going after this was to chase the long tail. Like every time you come up with an exception, you write a new rule, right? Yeah, the problem is there is no end to the long tail.
Full self-driving is an example of this.
Full self-driving. Yeah. Well, pick and pack. Picking an object out of a bin with a bunch of other objects in there that might be the wrong objects, right? Or might be a mixture of objects in different sizes, shapes, mylar, reflective material. Like, how are you going to do that? And the thing, and we talked about this before, I don't think it was on the recording, but I'll bring it up again. Like having 80% accuracy is fairly easy. The academics do that in the lab all the time.
Yeah.
Getting to 90% accuracy is actually not that hard. Getting to 99% is actually hard, but that's not good enough. 99% is not good enough. If you do 100 motions per hour and you fail once per hour, it's going to cost you more to fix the problem with the human than it is to actually have the robot.
This is why 5 nines matters.
Right. You need to be in the 999. You need to be multiple nines. Right. Yep. So like, how do you do that? Well, you put a lot of intelligence, compute on the factory floor, right? Yes. You have cameras, you have deep learning, you have a system well, a factory floor isn't a great place to have all that compute.
Nope.
It's not. It's a threat vector. You don't have the expertise on staff. Some of these large systems require very, very special environments with cooling and it's expensive. It's like a rack of GPUs can be $1 million.
And so this is what's driving what you had said earlier. You said in a previous podcast, I think, about data centers, the explosion of data centers across the world, correct? Like that you believe that accurately, I think a lot of people believe this, but is it that fact that putting the intelligence on the plant floor is not practical or manageable?
Well, it's not practical in two places. It's not practical on the plant floor from a cost perspective, from an operational perspective, from a CapEx perspective. It's not practical, and it's not practical in the cloud. Cloud's too far away. Correct. You might have data locality requirements. You cannot send the data farther outside of the jurisdiction or outside of our campus or outside, there's restrictions. Then there's like latency, right? Like if you're trying to protect pedestrians at an intersection by fusing the sensors from 4 or 5 cameras and maybe some other things, you can't rely on the unreliability of the internet or the timing, the latency, right? If you're trying to control a mechanical lathe, right? You can't afford to have, jitter in the line and stuff. And
so let me, I want to translate this for the audience real quick because our audience is.
Well, I was going to translate it.
Yeah, go ahead.
Okay. So you have two choices today, and they're both bad. I can either build all this intelligence on my plant floor. I can bring in Honeywell or Rockwell or any of the vendors you work with, and we can do that, spend a lot of money. And now I'm kind of like stuck, big decision, hard to make, lots of money. That's why I'm not doing it yet. Or I could maybe try and do it in the cloud, but I can't, that's like batch processing. It's not real time. It's not actually solving my problem. So how do you solve this problem? Well, our answer is we build essentially a cloud that's right at the edge of your building. So if you look at like speed of light, 1 to 10 kilometers over a direct fiber line is negligible. It is land speed. So I can be 10 kilometers away and deliver AI into your factory for all intents and purposes if it were actually on the factory floor.
So this is like the near-prem concept?
Near-prem, right, which is the word I made up, by the way. So it's near-prem.
That makes sense.
Yeah, and so the idea here is really to create a bunch of catalysts. One is to reduce the CapEx. So now you don't have to buy it. Somebody else is going to buy it. Supermicro is going to put all these servers out there. And I can get it as a service. So now the vendors are taking more of the risk. They're sharing it with me. I get hardware refresh cycles that I'd never be able to do on premises. I don't have to hire the operational people. And there are third-party vendors, ISVs, that are going to come in and they're going to build software capabilities, either as an SI, because they're going to customize it, or maybe as a turnkey. So let's pick an example that isn't manufacturing. We can come back to manufacturing. Let's retail, right? Loss prevention, or automated checkout, or assisted self-checkout, right? Lots of room for improvement in all those things. But again, how am I going to process the 500? How am I going to process the 500 cameras that are sitting in the Walmart with real-time computer vision, let alone this Walmart, right? Because I can throw a rock. I live in Texas. I throw a rock and I hit 10 Walmarts. So think about the cost of putting a rack of computers in every single Walmart as opposed to having an infrastructure in a city. And I'll go into this more detail in a second, Walker, because I know you're probably craving to understand what this looks like. An infrastructure in the city where I can serve all the Walmarts in the region for maybe 4 data centers. And I have failover 4 times, which is many nines. And I've got a consolidation of my costs, and I'm now getting it as a service. So maybe I'm paying somebody per camera per month, not some other model.
So zero gap is the layer that sits directly on top of the data center infrastructure in near prem, and zero gap is the suite of AI solutions, or the fabric of data.
It's the platform. Okay. It's the data platform. It's the compute platform. It's a cloud. It's a GPU. It's an AI cloud, basically.
Let me talk. I want to talk for the audience just how.
So who is your customer though? Well, if I wanted to develop an AI application and sell it to Walmart, I would use.
Yeah. So we're like a cloud in the same way that we have the same sort of relationships both upstream to the developers and downstream to the end customer. So an end customer, a good example is the city of Las Vegas, right? They want to add computer vision to all of their cameras. They want to put 2,000 cameras out in the field. They also have their own internal network. They want 5G. They want all these things. And to build that on a platform that's already paid for and distributed by private parties, right? And to be able to get vendors to come in and say, okay, well, now we're going to offer this as a service, is a huge transformation in the way the city of Las Vegas buys things that look like capital improvements, massive smart city infrastructure.
Sorry, Walker,
but manufacturers the same way. But like our relationship might be with I don't know who the big SIs are in manufacturing, but let's just say Deloitte. I mean, right? So our customer might be Deloitte. Deloitte would like wholesale our capabilities from 5 or 6, same systems from 5 or 6 different people, the cameras, the AI, the inferencing, put an entire system together for a manufacturer. Or Industry 4.0 could, one of Walker's companies could say, yeah, we're not going to put a rack of servers because you're in one of these 36 cities that has zero gaps. You don't need a rack of servers and a bunch of people to run all these things. We can actually just run it like it's a cloud service, and you can pay for it.
But for our customers, the challenge that they're all facing right now is that the data that they would use to leverage zero gap to train artificial intelligence, most of them aren't even acquiring yet, right? It's connect, collect, store. So for those of you in our community, digital transformation is connect, collect, store, analyze, visualize. That's the first 3 to 5 years of your journey. And then it's find patterns, report, and solve. Find patterns, report, solve. That is your ML AI. That's the ML AI layer. Now it doesn't take you 5 years to get to ML AI applications. You could be 12 months into your journey and do your first application, but you're doing it with a limited amount of data because you're not currently acquiring everything, right?
Yeah.
You don't currently have a library of events that machine learning and artificial intelligence can ML can learn from and AI can make decisions on, right? But here's a really I want to talk about the latency thing.
Yeah.
By the way, it's stunning to me the number of people in our industry who do not understand the importance of low latency. Okay, so when you ask somebody to go to say speedtest.net and they want to test their internet speed,
Right.
it's stunning to me the number of people who look at just throughput, which is okay. When I'm connected at maximum speed, I am downloading 300 megabits a second of data.
Mm-hmm.
Never mind, though, that they didn't bother to look to see that the round trip takes 500 milliseconds.
Right.
Okay, so the ping, when you see ping, that is your latency. It is how long does it take when I send a message to get a response. In a fiber infrastructure, it is very common, like internally, it is very common to see 1 millisecond, but that's generally the lowest they measure. It's much faster than even 1 millisecond internally. Okay. Mm-hmm. When you are on a fiber infrastructure, say from your house to an endpoint here in Dallas, I live in Dallas, so we have data centers everywhere. And so it is very common for me to see a 2 millisecond round trip latency. Okay. But the moment you go to coax, you go to like Roadrunner from Time Warner, if you see 25 milliseconds, 10 times longer. Okay. 10 times longer round trip. If you see 25 milliseconds, that's a great number. Typical is 50 milliseconds, okay, which is 20 times longer, okay? So the importance of latency, having very, very low latency, cannot be overstated, especially when you are trying to learn from events that change hundreds or thousands of times per second. Okay, you're trying to learn from data points and this is one of my complaints when I talk about ignition. People will ask me, well, why can't I do it in ignition? Well, ignition, by inductive automation, that platform, because it's built in Java and it's so high up on the stack, best case scenario is you could reliably acquire data through ignition at, 100 milliseconds. That would be best case. You're going to set your RMS at, say, maybe 500 milliseconds. So I can collect data accurately every half second if I wanted to. But most people are going second to 5 seconds, which is why you can't be that high up in the stack to build these solutions, which is why things like zero gap are so important. That is zero gap near prem with a high speed acquisition capability, right?
Yeah. So boy, there's so much to unpack in there.
Yes.
First of all, I would say that even that definition of latency isn't enough, because it's not the average latency; it's the tail latency you need to worry about. And the tail latency is, of all the latencies that happen, what's the worst?
Yes.
And the variance there is the jitter. And so jitter is what kills you most of the time because it's unpredictable, right? And so when you're using shared infrastructure, like a shared fiber, shared coax, you always run into, if it's not designed with network slicing where you have guaranteed bandwidth, you always run into a situation where you're going to hit congestion, and congestion is going to, or fiber link's going to go down and it's going to go one other hop. So the things that affect your latency are how many hops, right? Which you can't predict unless you control the network in its entirety.
Correct.
How many hops?
Unless you own the infrastructure.
Right. Yep. And what obstacles are in place are those different places. I mean, every router has queuing and bufferings, and there's retransmits and all of this. And so the way you solve for that is, so the closer you move stuff, the better off you are, because you have fewer network hops. If I'm one hop away, I can control that hop. Right. And you also don't have anybody else on your network right there, that leg, right? So it's uncongested. Right. So you've just eliminated two of the problems. And what's interesting is once you've, when people have really measured this, what they've discovered is that once you've optimized the machine learning models, the bottleneck is the network.
Yeah.
The network.
Yeah.
And so you're talking milliseconds, ones of milliseconds, tens of milliseconds, hundreds of milliseconds. Okay. I'm talking microseconds.
Right.
I mean, I can give you latency that's 100 microseconds into your plant. So that literally is over a private L2 network that you control. So that is your network, your domain space. exactly what you want. It is if it's on your premises.
What's the biggest challenge in selling this? So like, for example, we gave you gave a more granular definition of latency, which I intentionally left out because of my audience, right? So I would never, what I did was I spoke in the language that I think my audience is speaking, right? And so the challenge is that in order to sell, you have to sell in a language the audience understands. You had to get more technical to delineate a very specific value proposition, which a network systems architect, a member of the IT department are going to understand. But the guy who's in charge of Industry 4,
totally,
right, isn't
that's not my customer really. Eventually, right? That's the person we're serving as a collection.
Where the value's created,
yes,
but that's not the customer. Right?
No, the customer, like I've been selling edge computing for 7 years, and I can tell you right now, the customer doesn't want edge computing. It scares them. They don't know what it is. Like it's expensive. It's like, what they want is fewer defects, less downtime, less loss. Better supply chain. And so that's as an industry we need to get to, because that's what we want to be selling.
So let's say I want zero gap, right? Let's say I call up Matt and I'm like, you know what? You convinced me. I've got a client down the street. We're going to go ahead and we're not going to put infrastructure on the plant floor. We're going to go ahead and throw it in a data center down the street. What does that journey look like? Because by the way, I'm learning for everybody who's on here, I'm learning about zero gap on the fly. Like I know I was given a quick briefing by my team before I got on this podcast. That's it. Okay.
Yeah. So let me give a little bit of a more explanation of what we're talking about. All right. So it's built on this platform called the Kinetic Grid that Vapor.io has been building for the last 7 years. And it consists of like real world infrastructure in 36 US cities today. And what that is it's a lot of fiber routes, thousands of miles of fiber that we've taken down, and we've lit those optics in a region. So you take a city. And actually, here's a better way to think about it. All right, imagine a giant data center, an Equinix 1 megawatt city block full of racks of computers, right? Now take that data center and break it into 7 pieces. I'm just making up the number 7. It could be any number, 7 pieces. And instead of having them right next to each other in the same building, or maybe in the same campus a couple buildings away, spread them across the metro evenly. So they're, or maybe not even evenly, where they respect the geography and the fiber routes and the fiber junctions and the potential end user. So, zoning, industrial areas, the airport, those sorts of things. So we can look at an area and we identify, 100 zones where we can lay down a data center and is ideal for the fiber routes and all that. And we say, okay, we can service that market. And then we'll drop down 3 or 4 data centers in the first locations that we choose. We'll hook them up all together with a fiber mesh that is the quality of an internet backbone. All right. So this isn't like, fiber optic to the home. This is 400 gigabits per second, massive Juniper routers. This is designed to be industrial grade. And so now we have this, this data center that's distributed across the entire metro. So what can you do with that? Well, smart city stuff for sure, right? Because that is the definition of a city. It is all over the metro. But you also have, a plant here, a Walmart here, a 7-Eleven here, a Starbucks here, police station here, a bus station, right? And you can service all those from the same common infrastructure. And so the kind of things that provides, well, shared infrastructure, the economics are indisputable, right? You don't have to buy a data center, so a whole bunch of reasons.
Yeah, but who's buying the who's
so my investors probably put $100 million into the ground, and Supermicro is, I can't tell you how much they're going to put out there, but we're deploying Grace Hopper super chips, GH200s, which is NVIDIA's most powerful commercial grade inferencing.
By the way, if everybody wants to know what's going on with NVIDIA, their stock price, it's the GH200. Okay, no one's going to tell you that's what's what's going on. Okay, I mean, why NVIDIA? I keep telling my kids, keep your money in NVIDIA. Where is the answer? Is NVIDIA so far ahead of everyone in terms of this technology? There is no emerging competitor. They're all by themselves out there in the market right now. And I don't know how anyone's going to catch up. It's certainly in the next few years. So NVIDIA is going to take over the entire market. So anyway, that's the reason NVIDIA is so valuable right now. But for the data center, do you have a data center in Dallas?
Yeah, we've got multiple data. We're live in 8 cities. And what I mean by that is we have production workloads running. All 36 cities have infrastructure, but the 8 cities, it's Chicago, Pittsburgh, Atlanta, Phoenix, Arizona, Los Angeles, Seattle. I'm sure I forgot one, but that's it. There's Atlanta. Yeah. Those are generally the live cities. So yes, in Dallas, and it's across the metro, not just in literally Dallas, the city.
Right. So you build a data center. Supermicro puts in the infrastructure inside the data center.
Actually, the data center is built in a factory and it's trucked to the site, and it takes us about 6 hours to set up.
Okay, so data center gets built
just in time data center delivery. Absolutely.
All right, but Supermicro is doing all the infrastructure inside the data center itself.
They make the servers. They buy the GH200s from NVIDIA. They put up to 4 of them in a. This thing's amazing. It's only like 2 rack units. And they ship those to us. We stick them in the racks. We turn them on. We hook them up to the cable, and we operate them.
Okay, so now you're providing value. So this is the thing that I find interesting.
Yeah,
you're providing value. It seems to me that the ideal go-to-market strategy is on the smart city piece. That is managing traffic flow and dispatching workers to places they need to be, and traffic cameras and all that kind of stuff. It seems to me that that's like the go-to-market, right? So that means you're selling to municipalities.
I mean, it is a natural byproduct, but cities are hard to sell to. They have long lead times.
So you're selling to the Starbucks, the conglomerate of Starbucks, Walmart. Is that what you're doing? And then
so we are mostly with the exception of a few direct sales where we found it's so important to have a co-development relationship with the customer. So like the city of Las Vegas is a good example. That is our relation with Vapor. But for everything else that we're doing with Zero Gap, it's all through partners. It's wholesale. So we sell to the Walker Reynolds of the world, or the Deloittes of the world, or the IBM Kyndryls of the world, so they build it into their solution for their customer, whether it's a turnkey off-the-shelf solution.
Got it.
Right. So like Milestone Video Security, they could port their system to Zero Gap, and now you could have the baddest ass computer vision security system as a service per camera per month if you wanted to, which is game changing. Right now, security systems are old Windows computers that sit underneath the desk of the guard.
So secure. I got a question.
Yeah.
So you're talking about go to market, and you're the CMO, and obviously I'm into marketing. You talked about on your recent podcast the dirty secret of product launches.
Right.
What is that?
Well, if I remember correctly, so the dirty secret of product launches is that you can launch the same product over and over again, and you can actually launch a product without actually launching a product. So let me explain this. So I learned this at Salesforce. I did a tour through Salesforce. I was I ran marketing for Desk.com, which was their customer service thing, and then I was the CMO of Heroku, and I learned the Salesforce way. And so Dreamforce is the entire year of Salesforce. Like the minute they get out of Dreamforce, they take a month off, and then they plan next Dreamforce, and then everything else they do that year is in support of that end goal. Like it's a really interesting planning exercise. But so do you remember Einstein? I mean, they talk about it now, right? Einstein is their AI product. So they launched that 2016 or something, right? And they launched it like a product. Mark got up on stage. They brought the Einstein product manager and all this. Einstein was never a product, not something you could not buy a SKU called Einstein. What Einstein became was a piece of every single Salesforce product. So Salesforce announced Einstein General AI. It's going to be exciting. Oh, you can't buy it now. And then they announced Einstein for for Sales Cloud, Einstein for Marketing Cloud, Einstein for whatever. And so that was one of the things, realizing that you can have these launch products that nobody actually ever buys, but you use them to coordinate attention. Now,
so how does that apply to your the Vapor?
I don't know. Well, so I don't know that I've actually used that technique at Vapor. Although, no, so I'll tell you how I think about it. Yeah, so it's not tricky. It's not designed to be tricky. So I call it this dirty trick because it's like fun. It's fun to call it that. But what it is recognizing that, I mean, at Vapor, I've essentially launched the same product over and over again. But what I've done is I've added capabilities to it, and I've had a better understanding of who the end user is. And I can tell you, 7 years ago, when I started, I thought the end user, just like everybody else, was going to be autonomous vehicles. because that's what everybody was talking about. That's what everybody said. That's what Google told me. That's what everybody told me, right? Then I thought it was going to be 5G radio because that's what everybody told me. That's what everybody said. And so as we've sort of iterated, I've had to launch a 5G product and this and that. Now I'm very confident I understand what the market is, right? It's to add AI to existing without the barrier, without the friction. It's to add AI to existing systems without the friction, and it's going to be massive.
Yeah, but let's say I'm a our audience is primarily manufacturers, right? So I think I have as a manufacturer, my focus is, I have two primary focuses. I want to commoditize data.
Mm-hmm.
That is, I want to take data. Okay, so I want to commoditize data. I want to take the events that happen across my business, the digital events, that is every sensor transition, every work order that started, every downtime event, all the things, every sale, every complaint by a customer. I want to take all those things and I want to learn from them, and I want to transform that into information that I could sell. Mm-hmm. Right? That's the commoditization of data. You
as the manufacturer,
absolutely.
You want to sell product and you want to sell your data.
Absolutely. Tesla, this is why Tesla will never be beat. But most people have no idea why Tesla is so valuable. Most people have no idea. Tesla is fully integrated from the car and customer on the road all the way up to the top of the cloud, where every single event that happens inside of their business is collected within context and fully normalized using a unified.
Yeah, but selling the data that the cars collect is very different than selling the data that their factories collect.
Oh, but no, that's why. I mean, when Elon says our real value in the business is our manufacturing, what's the hardest part about manufacturing? Think about it. Let's ask this question. When you have a new product,
100% uptime, that's the hardest part.
Yeah, no, it's getting started.
Oh,
more than half manufacturers go out of business before they ever produced one good part.
And why is that?
Because it's really, really hard to manufacture stuff.
Yeah, it shouldn't be.
Agreed. But why is it that still in 2024, more than half of all manufacturing startups fail before they ever produce one good part? What's that?
Why shouldn't it be hard?
Yeah.
Because people have done it before, and we should be able to make it repeatable.
Well, like Rivian is struggling with that now. They're struggling to manage.
I'm not saying it should be easy for them. I'm saying as a society,
we should make
it's too hard. It's too hard. Yeah. Well, okay. So the general approach to make manufacturing easy.
Yeah.
The general idea had
product design.
Well, no, it had been the way the Germans do it. So that is, you'd use like a hybrid economy where you've got, 30% of all manufacturers are owned by the public, and then 70% are owned by those who have started the venture. The contribution from the public is capital and knowledge. We have previously launched initiatives. We know how to land a plant, get it producing good parts, and implement a continuous improvement strategy so that we can reduce downtime, we can increase the quality of the product. That's been the traditional approach. The traditional approach has been, let's do a hybrid of public and private investment so to make manufacturing easier. That's the United States tried to do this with SESME, with the Smart Manufacturing Institute. It has not gone that well. Okay.
Let me ask you a question.
Yeah.
So so my answer, Zach, to this is like, okay, if I wanted to start up a factory now and I knew that half of them failed, I'd hire Walker. And so then the question is, can Walker stand up a factory better than most other people? I probably, or at least tell me why I shouldn't do it because I've got the wrong idea. And then, so then the question is, could we, through a combination of artificial intelligence, software, standards, make a system that implements what Walker knows needs to be implemented, but just does it with more interchangeable parts than exist today? Yes, we totally could do that.
Yeah. But the question is, why don't we do that? Right. So the reason why not everyone
it's Honeywell's fault.
Yeah. The reason why not everyone hires Walker is because there's only one Walker. Right. Sure. I can only help in a year. I can help somewhere between 16 and 20 companies. Okay. If you look at the number of organizations I help in a year, that is directly with my architectural capabilities, it's somewhere between 16 and 20. But I'm doing that through an entire team of engineering staff. I got 4 leads, and then you got all.
Yeah. So let's build a factory for Walker.
Correct. That's what we're doing internally. And what I'm saying is, what I'm asking for clarification is what you guys are offering with zero gap, the combination of this infrastructure and platform, is it the platform that's supposed to make it easier for me to develop the primer that is used to deploy?
Yes.
Okay, got it.
All right.
So you are going to be better at talking to and selling to manufacturers than I ever will be. I'm going to be better at building infrastructure at the door of your manufacturer than you ever will be. That's a great partnership. I actually want to take this in a really interesting direction. So I watched your recent video on the remake of the Digital Factory, right?
Yes.
And I started thinking about the Digital Factory and the universal namespace and things like that. And the thing is that in your world, this idea of universal namespace is like, doing, light bulbs go off. In my world, universal namespace has existed. I mean, what do you think the internet is? It's a universal name. So DNS is universal namespace.
Right.
And in marketing in particular, so you talk about, okay, what does it mean to become a digital factory? Digital transformation, data as a commodity, all these things. All that work that you're teaching people, the marketing industry is doing the same thing. So marketing has its own equivalent of manufacturing data, right? And data it needs to get data. So if in the marketing world, if you think of the marketing as the OT for marketing, right? It's our new world. We're dealing with things that nobody else knows about or cares about. But I need information from the sales system, and I need information from the manufacturing system. Maybe I need information from customer support. I need information from finance, right? And so marketers are saying the same thing you are. They're just
customer 360,
and they put it through the CDP, customer data platform, right? And so what's really interesting is it's not just the factory of the future that needs the universal namespace and the integration of IT and OT. It's every business needs the universal namespace. And here's the cool thing: I can give you a universal namespace. I can give you a data fabric that already has a universal namespace. So you just tell me what data you want.
Unified namespace.
Unified. Sorry.
Yeah,
it's.
But if I didn't say anything, the audience.
Sorry. What did I call it?
Universal. Yeah. That's probably how it translates to your world. But yeah,
it does. Yeah. But we know what it is, right? It's like a thing I can query for any piece of information that my business has collected.
Correct.
And it's a single source of truth. That's what it is. Yeah. And
every business does need that. Yeah.
Yeah. And at scale, it shouldn't be a SQL database. At scale, it should be a fabric that's massive, especially if you have multiple locations.
Yeah, and I try to explain this with UNS because there's been this huge explosion. I try to explain to people that, what is a unified namespace? So the best way for me to describe it is imagine it's a table. The fabric is a really great way to explain it. And imagine, I have my phone here, which has, it talks the language of the table, right? So this is a node, and it would be the node ID. The node would be my phone, Walker WDR, whatever, iPhone 14, whatever phone this is. And there's functions inside of here, right? Each app is a function, and inside of each app there are sub functions, and there are information layers, and there are data layers, and so the idea of the unified namespace is I take this phone and I set it down on the table, and now anything else on the table has access to the stuff in the phone in its structure, and the phone has access to all the things that are on the table, right? Now, it's a very simplistic explanation, but it is amazing to me the number of people who struggle with what that means, right?
You're talking about example, Vapor would be kind of the table.
Right? Vapor would be a tablecloth on top of the table.
Got it.
Okay.
I just introduced the cloth.
That just made my head pop.
Here's
the fabric.
Right. Well, no, my point is that Zero Gap, the platform, would be the tablecloth on top of the table.
What's the table? It's all your systems and your facility.
The table is the native infrastructure.
Got it.
Total,
okay.
And
right.
That
works.
And then the tablecloth is the thing that we put on top that it because you can do it. You don't have to use Zero Gap, but you have to have common technology. Zero Gap is the platform on top of the common technology. Right?
Yeah, and it's the one that allows you to bring AI at scale and at economics. That makes sense.
That's the unique piece. The part is when you grab the tablecloth, that's the layer. That's the common AI layer, right? It's my question is, how do your customers develop solutions for that platform that are then available?
Yeah, so we're evolving, okay, but that's the direction we're going in, right?
Got
I
it.
mean, today it's early adopters. It's every deal's a new deal, right? We're just now deploying the hardware. I mean, there's the GH200 just came out. There's a 32 to 52 week wait for most customers. Now, we don't have a supply chain problem because Supermicro is our partner, and Supermicro's NVIDIA's largest server partner. So we're able to get these things. But it's going to take time to deploy in 36 markets. So we do market at a time, customer at a time. Yeah.
I want to pivot back real quick to data as commodity, and I want to read something to you to have you explain on Zero Gap. But
okay,
data as commodity. I want to go back to this. What does that mean? There are two cases. There are two primary applications for data as commodity. Number one, it's internal use cases. It is, how am I using my own data to make us better? Okay, right? Mm-hmm. That's primarily what we talk about. 99% is how do I collect it? How do I connect to it, collect it, store it, analyze, visualize it, and then find patterns, report, and solve problems that I have internally. Okay.
Number two is using data as a product you sell to your customers.
Correct. Totally. So if you look at Snowflake, for example, when somebody goes, why should I use Snowflake and not S3? Okay. Well, okay. The reason why is because Snowflake gives you the ability to take the value you created from your data and sell it to other people who could benefit from your data. For example, let's say I'm in the life sciences industry. Okay. And one of the biggest challenges you have is you want to improve the yield of batches of drugs that come out of a bioreactor in life sciences. Mm-hmm. And there is a specific problem you have identified with a bioreactor from this manufacturer. Okay. And it has to do with the relationship between, this agitator and this pressure gauge, whatever it is. If I build a solution that allows me to solve that specific problem, platforms like Snowflake give you the ability to sell that solution to other life sciences companies. The raw data.
Sure. Yeah. And I think that's,
I'm a smart city and I collect data on traffic light information, the number of people who run stoplights. And what I want to do is build a solution for other cities. And I want to incorporate the data that you have available. The commoditization of data is you selling me that data that you have.
Yeah. I actually don't like calling it commoditization. It's more like it's the monetization of money. It's not really commoditizing. No, you're absolutely right. So two things are happening. One is it's becoming increasingly easier to collect and store massive amounts of information. And where it used to be information pruning was really important. Well, let's figure out what to throw out because we don't want to store it. Well, no, storage is so cheap. Networking is relatively cheap.
Right.
The deep learning models need lots of freaking data. Yep. And that's hard. Yep. So if you have real data and they're trying to train with simulated data, they're going to want your real data. So I definitely agree. Now, I don't know enough about life sciences to know which of their data will be applicable to others. Certainly in the smart city example, there's lots of examples. Yes, you got 2,000 cameras in, say, Las Vegas. It's going to collect a lot of information. The way that people are thinking about it, though, is there's a lot of in smart cities, there's a lot of privacy issues. And so the idea is that you could subscribe to a certain subset of data. So you could subscribe to the car metadata without the identifying license plates. So those would get blurred out. You'd get bounding boxes of the cars. You'd get the analysis of the cars, like that's a red pickup truck, that's a white whatever. You could run your own models against it, but it's de-anonymized. And then you've got like the forensic stuff, which the law enforcement needs to subscribe to, and it's got its own, so that's auditable and whatnot. And so I do think that secondary market.
How do you handle this? I wasn't even going to bring this up, but like for example, most people don't know in the state of Texas we don't allow like red light cameras and stuff anymore, and it was a privacy issue, right? As opposed to the state of Georgia, which still allows just random license plate readers. So they can just read the license plates of vehicles on the road. In Texas, you cannot do that. It is against the law. You cannot just, you can't just read a random license plate in the state of Texas. You're not allowed.
The police can't? They can call it in. They can call it in manually and they can't read it?
No. They have to have a reason. They have to have a reason.
But all these parking things that do auto.
That's a that's a social contract you've entered into.
Oh, okay.
When you right. So
Yeah.
what
So it's different, but state by state, yeah, it's absolutely different.
you
I understand that.
can't just randomly read. You know what I
Okay.
mean? Like here, if you're on a public road,
Yeah.
you can't just capture someone's license plate. The government can't do that. We limit that here in Texas. It's
Right.
not limited in states, say like Georgia. How does your organization, how do you guys deal with?
So that isn't our job, but I'll tell you, there are people that do this. So there are people that would take that. So let's assume that the law would allow us to put the cameras up.
Yep.
So long as we anonymize the video, we blur out the things. Okay. So assuming we can set that system up, somebody else is in that business, and they would need to do that.
It's your customer. It's your customers in that business,
or our customer is OEMing it from the person's in that business and assembling a total solution.
Got it. Okay.
Yeah.
Perfect.
Yeah, that's right. Now we do things that may enable that. Like we can get the data to where it's needed to be processed by that other person, probably better than anybody else, because we have a national backbone and we have all these local networks, if they're one of our 36 cities. But other than like that's the role of other people.
Here, by the way, I want data as commodity. The reason I use the term data as commodity is because as we have more data, the raw event itself becomes less and less value unless the demand for it goes up. That's the reason but the real value, the monetization of data is in the conversion of data into information. The information itself is what becomes the thing that you really monetize instead of the raw event. The more raw events we have to learn from, the less valuable each individual event is, and less the demand goes up at the same rate as the volume of data is collected. But the real value, the monetization of data is in the conversion into information, the actionable component. That's the reason I use.
And I think there's going to be a really, really rich market. So all these companies in the business of training models are going to be competing against getting better. They're going to be competing against getting better data. So there's going to be a great market.
Because the trained model is no longer super valuable because you didn't really write a lot of code to do that. You really just trained it on the data. So the data is more like whoever has the best data.
Yeah. So it's there are a lot of really hard problems left, and there are companies that are it's not just like I just pull something off the shelf and I run it in Python and suddenly I've got a system that can do these amazing things. And Pick and Pack is a great example. I know quite a bit about that because I spent some time with Peter Abiel at the Berkeley Robotics Lab, and Peter Abiel. Abbeel. Yeah. He runs the Berkeley Robotics Lab, and he's a co-founder of Covariant, which is a smart robotics company in Berkeley.
And Matt is a UC Berkeley alum.
Yeah, I come from UC Berkeley. Yeah. So but the interesting thing is that what they've had to discover is you can't just train it on a bunch of data, because first of all you're going to encounter this long tail of new novel situations in Pick and Pack, right? And so you have to train it like at a higher level. You have to teach it that it has to look at the box and identify the objects, identify the shape of objects. It has to then figure out which object it wants, and then has to figure out whether it needs to move other objects out of the way. Right. So it is kind of reasoning like a human. And in order for Covariant to make the robots do that, they've had to train at every level. And they've had to invent ways to make it easier to train it on the field. So they have this really cool, like we call it one-shot training, where the human will demonstrate to the robot what it needs to do. So they'll have an example where it's like a blue cup, a ball, a plate, and a square. And the person will take the ball and stick it in the blue cup. And the computer gets to see it once. And then it will repeat it, and and you move the stuff around. It'll say, "Take the blue ball, put it in the red cup." That is really hard to get reliably, 5 nines, reliably right. But if you do, you've completely revolutionized Pick and Pack in warehouses. Warehouses have like 1 million SKUs.
Let's talk about the nasty little secret in AI. Okay, All right. What happened with what is Google's platform again?
Gemini.
All right. Absolute shit show. Right. Couldn't have been a bigger shit show. Okay. I have friends who work at Google that told me, hey, listen, not surprised that happened. So for those,
it's a PR disaster, but it's a great product.
It's a shit show. It's a
why?
You're in marketing, Matt. Full well you get one shot at making a first impression.
But maybe first impression, sure. Okay, so
but
they're gonna roll it out in all their tools. Google owns all the patents. Google owns the transformer patent.
Yeah, but here's the problem.
They're gonna do just fine in AI. Okay, sorry, I'm interrupting you. Go on.
No, they're not going to do fine in AI and industry.
Okay, that may be true.
If you take a look at,
I buy that.
By the way, there's nobody, you'll see in the comments down below. I want one person, anybody to tell me that they have built their cloud infrastructure based on Google Cloud for Industry. And there will be no response. There will not be a single person. Here's what's happening, and here's what I'm hearing. The idea of shared AI, the idea of shared ML is running into a lot of resistance in the market. Okay.
Explain what that means to me, though. What is shared AI, shared ML?
For example, if you look at the idea that what I'm going to do is I'm going to lease out my AI capabilities to a platform, or I'm going to lease out my AI. Let's use ChatGPT as the example. More and more companies are saying, no, we want something like ChatGPT, but we want it only trained on our data.
Yeah, but you would still start with the foundation model and then fine tune it on your data. You couldn't afford to train your own model.
Wait, say that again?
You would start with a foundation model and you would fine tune it.
Well, you can't.
It's RAG. It's
Kathy Wood would say cost of training models is dropping by like 73% per year.
But why is that? Why was it so expensive for OpenAI to train ChatGPT, GPT-3? Why was it so expensive?
Because it's computationally expensive.
Because they had to put in $5 billion to build a data center underwater. But that's a one-time expense. So like when I spend $5 billion to build a data center underwater so I can do all this computation, right?
It still requires a lot of energy, the input.
But what percentage of the cost was what they paid for energy, and what percentage of the cost was the capital expenditure for infrastructure?
You're amortizing that over the runtime, how much compute time you're using. It was
90-10 over the first 12 months. Yeah. 90% on infrastructure, 10% on the commodity of energy.
Sure.
And guess what? Over time, that energy, the cost gets higher because you're amortizing that 90% over, let's say 5 years probably is the lifespan of the infrastructure. Let's say maybe 10 years. So you're going to capitalize that every 5 years, every 10 years. But my point is that training models is getting cheaper, not more expensive. It's getting way cheaper.
Okay, that's a very general statement. First of all, and training is,
the audience will love me being
okay. So training is way more computationally intensive to build the model than inferencing. But inferencing is way more continuous.
Explain the difference for our audience.
So you're right. Training you kind of do once. I mean, I'm exaggerating, but like training is a big thing that you do.
You do it in a product lifecycle management. But
you climb the mountain first, then you put whatever flag down you want. Right.
FSD is a great example.
So inferencing. And I'm oversimplifying this. It's when it's where the model is used. So you make this giant model that's able to look at data and create a response.
Correct.
Whether that's type I text in or an image I get, or whatever, to generate a response that's an actionable. So it takes data and turns it into information. Right?
That's the model.
That's the model.
Training a model. It's the model.
Now I can make a model and do nothing with it, and it's useless. So I have to inference over that model. Now, generative stuff is a combination of training and inferencing at the same time. It's generative is different, but let's just give me some data and I will tell you like what's in the picture, right? That happens at runtime, and the model is relatively fixed, although there may be continuous lifelong learning that happens, fine tuning that model out.
And there should be, and there should be,
absolutely, there should be. But what's different about that, the amount of compute and power and all these things to run an inference over a single frame of video is tiny. Video can be very high def, especially in mechanical inspection. Excuse me, I'm gonna sneeze.
Bless you.
I was able to mute it fast enough. But it's happening 20 times a second, 30 times a second, 60 times a second over hundreds, thousands of cameras, 24/7. So the amount of compute that's needed to process real-time inferencing at scale is way more than ever is going to be needed for training. Even though today, it's different because everybody's been investing all their money in the models. The joke in the industry is like you spend money training your model, you make money inferencing over it. Yeah.
Elon put it like this. He said the first time you learn how to drive a car, you're training your model. You're using a lot of your brain power to learn how to drive. Now we drive secondhand because we're just inferencing that model that we've already trained.
That's right. And fine tuning that model is like learning a new skill in your, it's
but
like,
on aggregate, we're using way more, even though because everyone's driving all day, every
constantly.
day. So,
yes, exactly right. Yeah, it takes a lot of compute to analyze 30 frames per second across 2,000 cameras. Like, just do the math. It's petabytes of data. It is huge amounts of data.
It's a huge. Okay, so my point is, though, here's my point. As more and more people need compute, we invest more and more capital into computational power, right? We have unlimited silicon all across the globe. We have massive capital investment in the upscaling the infrastructure for manufacturing the chips we need to do this. I'm an investor, right? I have $60 million tied up in investments right now. Okay. I meet with a different VC every week who wants me to put my money into their investments. Okay. I have staked generations of my family's future on the absolute certainty that computational cost will be minuscule. It'll be so unbelievably cheap. It'll be so we won't even be able to wrap our brains. I think about it like we talk about the inferencing piece. From a theoretical perspective, I agree with you, but from a practical perspective, I'm like, well,
I think I want to. So you're saying computation can get cheaper while the demand for it is still going up and on.
Yeah. I mean, first of all, Jevons paradox.
Yeah.
Right. Right. So the more cheaper you make something, the more of it's used.
Yeah.
I definitely think it's certainly been in place in technology and compute technology since I've been alive. But also, yes, the cost will come down, but it will become more common. Right. I mean, I think when I look at where the this naturally plays out, which may or may not happen because real world is kind of messy, but I see this moving towards kind of what the academic call is pervasive AI or ambient AI, where literally imagine a world where AI is available like electricity. It's in a socket. So you want to do inferencing, you plug in a socket, you send your inference, you get back. Now imagine a world like that. Imagine what we could do. Imagine all the things we could do. We make everything smart and intelligent. And I'm in the business of making pervasive AI available per unit of time or unit of compute. And if I can make it available like it comes out of a socket, right? Like that like electricity. Because I don't think anybody wants, why would anybody want to own a computer when you have the internet and the cloud? And like the only reason you want to own a computer is because you can't get what you want without owning it.
I think I'm a sociologist, Matt. I believe technologists are vastly underestimating the impact of a human being's lack of trust in large organizations. Vastly underestimated.
So what's
the Google piece?
Yeah. I mean, put it in perspective, right? I'm a technologist. I just in this office alone, I have 7 or 8 over there.
Yeah.
I use cloud technology, a lot of it. I mean, I have AWS, I use Vultr, I use Azure, but there are 2 fundamental reasons why I own the infrastructure. First and foremost, TCO, calculating total cost of ownership for cloud infrastructure, is impossible. It's designed to be impossible. It is designed for you to not be able to calculate how much you're spending. It's designed to do that. And the longer cloud providers do that, and the longer they do that, the less people will trust them. The more often you test models that Google develop and you realize they don't produce a white person. By the way, I'm not white. I'm Native American. I am red. Okay. So I don't have a dog in this fight. Okay. I'm Native American. But the more often that you go and you test these models and they do stupid things, and then you find out these large organizations have massive agendas that are outside of solving your problem. And by the way, this is fact. This isn't conspiracy theory. It's Google has a huge agenda to recraft society. They have, and they're not the only one. Microsoft has one. They all have these agendas.
OpenAI, yeah.
And OpenAI has it. They want to reframe what society looks like. Now, I'm not going to argue whether that's right or wrong. I understand where they're coming from. What I'm saying is that creates mistrust when you're not upfront and open about that. If what you do is you go to a model that was trained by another company and it produces the first president of the United States as a black woman. Okay, I mean, that's what happened.
Right, but those are apples and oranges. Right? So producing a general purpose,
it's not
large language model that's in V1 that you can trick is not that big of a deal.
Matt, it's only apples and oranges to the experts in the field, which are 0.00001% of the population. In order for you to get wide adoption of AI as a service, then what you have to have is wide trust in the market of AI. In order for you to get wide adoption, you must. I mean, you can't.
I mean, so I'll take a different take at this. Yeah. So I don't necessarily disagree with you. I haven't fully absorbed it, but I will say this: if your company, if it's an existential question that you either need to adopt AI at scale or go out of business, I'm not worried about it. That's what's going to happen.
Oh, no question.
AI will 10x your business or put you out of business. So I'm not worried about people wanting it as a service. Some large percentage of the people. Yeah, sorry.
But you have an option, Matt. Now, I'm not saying that people are choosing whether or not to leverage AI or not. Yeah. What I'm saying is they have a choice about whether or not they're going to outsource it.
Oh, sure. And they always do. And I've got to have a better value proposition, and maybe part of that is a better trust proposition. Totally. Oh, yeah, 1,000%.
And guess what? Manufacturers are not outsourcing.
Well, okay, maybe not. But I have a different value proposition. I'm not a cloud. I give you, it's your network. It's a private network.
Yes.
You can get the whole machine if you want. If you don't want to do a virtual machine with other tenants, I'll give you a bare metal GH200. It's yours.
I'm defending using what you have to offer.
Okay. Yeah, I'm saying, but dude, yeah, sure. If we violate people's trust, and we don't have another agenda, like we're not selling anybody's data, we're not collecting anybody's data. I mean, the data, so we do generate, you'll appreciate this. We generate billions and billions of data points, but it's the OT data on our network and platform. We have 80 sensors in every, we have quarter rack level temperature and pressure sensors. We have sensors on.
What's the capital expense? Let's say I wanted, I'd love to see what these data centers look like because you're shipping them. They look
like. Well, so we have three sizes. We have a 20 kilowatt version, which is our smallest, called the VEM20 Vapor Edge module, and it fits in a parking spot purposely. It's about the size of a UPS truck. Okay. Then we have a 160 kilowatt and 180 kilowatt, and they look roughly like a shipping container.
Okay.
They're purposely ugly, which the marketing person doesn't like, but the security people do. And they're just these metal boxes that.
And how much does that cost? For me to get one of those in my parking lot costs it? You can just be generic in your response, but
it's not quite so. It depends. So we don't sell.
Are you saying how much it costs him, or how much?
Yeah. So we are able to make so the way they measure data center space is in megawatts, right? And we're able to manufacture data center capacity for about 25% of the cost that Facebook has to.
Because of the way you've made the machine that makes the machine, kind of,
yes, that, but also a really interesting thing that if you look at how data centers maintain fault tolerance, they duplicate or triplicate everything.
Right.
So they'll have 2 chillers and 2 backup generators, right? So you have all this extra equipment that you hope never gets used. It's just a waste. So what we've done, because imagine a large data center in 7 pieces, each of which has its own redundancy because it's a separate piece, but it's spread across the network. So when you sign up for a service on Zero Gap, we don't just put 1 fiber line to your plant. We put at least 2, one from a different data center. So if there's a fiber cut or there's a network outage or anything, you've got a backup system. Now,
and when you say data center, you mean
of these Vapor Edge modules. Well, so we've actually so most of the data centers that we've deployed today in the US are our own modules on land that we lease, on dark fiber that we lease that we've lit with our own optics. That's our basic model.
So what that means to the audience is dark fiber means cables that are not currently being used. No one else's network is on that line.
Yeah, and we put a lot. I mean, we have some of the best network engineers in the world, and we light our with PAM4 optics, which is almost unheard of. But what's unique about PAM4 optics is over short distances, like a county or a city, it's very fast and very inexpensive. So
how do you encourage people to do disaster recovery? So I mean, obviously, DR, like a DR environment, you could basically do this with just two of these pods next to each other, right? But that's not a good DR strategy, especially in the event of like an earthquake or something, right? So how do you encourage people to do DR?
Well, so actually we don't call it DR, even though that is kind of what it is. So we call it high availability.
Got it. Okay.
And it's software-based high availability. And like Kubernetes does it out of the box.
Right. Okay.
Right. Because again, the difference between two Kubernetes pods running on two racks 10 kilometers apart, from our perspective, they think they're in the same data center. They don't know. And so the sort of, when something fails, it gets restarted. And so the basic model of a hyperscale data center restarting across, racks that are distributed is common, but within a single building. What we've done is we said, well, you actually do it at the city level. And so we don't need any of that redundancy. Like each unit has a tiny bit of redundancy, right? Like we can correct for things with the chiller doesn't quite do right. But like our redundancy model is to shift the workloads to the next nearest spot.
Distributed.
Yeah. And
within the city.
And again, because the customers that we're targeting are the people like you, Walker, or like Covariant or stuff, where they're looking for, they need 5 nines of reliability, not just in their AI algorithms, but like an uptime of their AI algorithms. They know they want this already. Like this isn't a hard sell. Whereas years ago, people thought we were crazy. Like the idea that we were pulling real-time data off of our infrastructure systems and then sharing it with our customers. Like you go to any other data center networking company, and you say, I want the internal network box data on congestion. They'll be like, take a hike, because you're just going to come back and kill us with SLAs. And we're like, no, you get everything because you need it.
Isn't this something you're kind of running into with fullstrength.ai, Walker, where you have like to run the model is actually quite computationally expensive, and that's why it hasn't gotten onto the phone yet.
I mean, inferencing is cheap. Running, training the model is expensive for us. The model training
computationally expensive, or like because it can only run on certain hardware, right?
Well, because we've architected the solution to be inferentially lightweight.
Yeah.
Like
and there's a lot of use cases for that don't need my infrastructure.
We designed it because the goal was to ultimately have it run like on a phone. But that was one of our unique requirements, right? So for us, it's inverted. To train the model, because we're using things like MediaPipe and then our own models, we're training them every 90 days or so, give or take, right? And so we train the model, and then we deploy the model, and then we're inferencing when we're looking at an athlete, right? And the inferencing
still run in real time.
Yeah, runs in real time. Yeah, so literally we're looking at a live camera of an athlete going up to a deadlift platform or bench press or squatting, and we're estimating the pose, which that's one set of inferencing going on. And then what we're doing is we have a second set of inferencing looking at how much weight's on the bar. And then there's a third set of inferencing looking at the hand position. Then we're calculating, there's a fifth inference, which is calculating the center of gravity. And then we're calculating force and velocity. So it's not just one model, and it's not just one inference. It's many models and many inferences that are all working together. We try to keep things linear. That way, the overhead is really low.
Yeah, that's what I was going to say. The minute you start trying to do things like sensor fusion in real time, where you're trying to take accelerometers and merge them with cameras and these kinds of things, you need to be running in parallel. And then the single shot solution isn't very good for that. But yeah, you can push these models. You can go to 8-bit integers, and they're surprisingly good.
So for your data centers, though, for real quick your data center, that's a Vapor IO product, or is that Zero Gap?
So it's a Vapor IO product. So Vapor IO sells networking, co-location space. And so literally, if one of your customers just wanted to use one of our data centers as they want to rent a quarter rack and our network, that we'd sell that to them. That's our core Vapor IO product.
And that's in Austin. You guys have data centers in Austin that are you doing this?
No, we're headquartered in Austin. So we have 36 live cities where the Vapor IO kinetic grid is, and we're rolling out the Zero Gap platform to all 36 of those.
If I buy one of your pods, let's say, and I want to put it out.
We don't sell it. We don't sell them.
Oh, okay, got it. All right.
Yeah. So there are people that sell micro-modular data centers. Dell sells them. Schneider Electric sells them. If all you want to do is put a data center in your parking lot and spend a couple $1 million to do that, go to any one of them. But if what you want to do is build a network like ours that's remotely operable, that we can apply AI to the own system to self-remediate, self-correct, you can get the data streams. You want all that, you got to buy it from us because we built it and it doesn't exist anywhere else.
So this is the distilled description of Zero Gap. Zero Gap is the part that really appeals to me, and I want you to take this and translate it for our audience.
Okay.
So it says one of the key features of Zero Gap is its ability to offer AI access points across entire markets.
Yeah.
Creating a mesh-like network for AI services.
Yes.
Okay. And this comes from I think Datacom or somebody did a press release. Or Datanami did a press release.
Okay. They wrote about it. They wrote about the story. Yeah. Okay.
February of last month. It says this highly distributed architecture can instantaneously deploy AI micro clouds where needed, keeping data local, which is crucial for data sovereignty, locality, and compliance. Moreover, Zero Gap AI can be delivered over both wired and wireless networks with a standard setup, including a high-speed private network connection, if necessary, even built on private 5G. Okay. Yeah. Translate that to
which part?
the part of offering AI access points across entire markets. Okay. If my market is discrete manufacturing, let's explain.
Oh, I made a geographic market.
Oh, okay. Okay, got it. Over entire geographical markets.
Yeah, sorry, that's what I call a market. That's a good. I'm glad. I'll have to go fix that. Yeah, across access points across geography. So literally, those are data centers spread across the geography.
Got it. And then the let's talk about micro cloud. Well, I know what a micro cloud is, but AI micro cloud is a new.
That's just marketing horseshit.
But what is it? In application? What does that mean for a manufacturer?
So what I meant it to mean, and it's a metaphor, is this idea that, like, what is a cloud? Well, a cloud is virtualized compute and storage that I can kind of use anytime I want.
Correct.
And so I was trying to come up with how do I describe like your own right next to you, right? And so microcloud, it's not a great word. It's not a great sentence. It's not very explanatory. But I was just trying to introduce a metaphor in the thing. There's no formal definition of microcloud.
Got it.
Although maybe I should do that.
No, I mean, I think it's. I mean, I when I read it, I get the gist of
that. That's all it was meant to do, was to kind of get you the gist. It's not literal. But it's like it's cloud-like functionality. You pay for it as you go. You can tell it where you want it, and it will show up in that location.
So before we take it home, let me. I kind of want to close with this discussion here, and the biggest challenges in artificial intelligence right now, and I don't mean in the practical application of AI, but more in go-to-market.
Okay.
What do you see are the biggest challenge? Like right now, if you just look up artificial intelligence, right? And what you're going to see is the holy war between OpenAI and Elon Musk. And, you're going to see Google's Gemini is biased. You're going to see like all these things, like the messaging's not going to be positive. If you like Google, the message is going to be negative. Okay. And so I think it's very hard for people right now to find accurate, meaningful, purposeful messaging on the value of artificial intelligence for manufacturers. Okay. And I think the best way to address that is let's have a conversation about what are the biggest challenges right now with artificial intelligence as it relates to go to market. Besides the obvious access to reliable data, right? Access to reliable data that's normalized, contextualized. We all know that that's a huge problem, and Industry 4 is working on that piece. That's what we're trying to get manufacturers to transform. What are the biggest challenges the market's facing as it relates to artificial intelligence?
Boy, that's a big question.
Well, if we distill it down to one or 2 points, there's got to be a couple that you're just like over a glass of red wine at night. You're like, motherfuckers, I wish they would figure this out. Or there's got to be that thing, Matt.
Well, still, for a lot of like real world use cases, it's still too hard. So I think a lot of the successes we see in academia or early starts, where again, it's like maybe 99% accurate. That's not enough. Because like if I'm one of these, all right. Okay. So my Walmart just ripped out and replaced every single one of their self-checkout machines. That must have cost them a fortune. The old ones sucked. Like you could not get through a basket of 20 items without having the person come over once or twice. Right?
Tom, by the way, here in Dallas, Tom Thumb is the only company that got it right.
Okay, so the new ones in Walmart are great.
Yep.
You can take things out of your cart, scan them, put them back in your cart. It knows you didn't steal it, right? Like these are great. They don't fail.
They're no longer using weight as
right. It's just like, and that's because of AI. Like they've got a computer vision system that recognizes you took an object out, scanned it, and put it back in. It knows what objects you haven't scanned yet.
That's right.
Like that's super impressive, and it just makes it so great for us as people using this checkout system. So I think, and I go across every field. Whether it's a surgeon with laparoscopic or endoscopic surgery trying to real time recognize polyps that need to be removed. You can get a 25 to 50% increase in accuracy of polyps in colonoscopies when you have real time AI assist. It has to be real time and it has to be really accurate. We're getting there. So I think that's what needs to happen. It's like, and it has to be just embedded. Like the radiologist isn't going to buy AI. They're going to buy a new
tool.
Right. And it's going to have AI. And hopefully its AI isn't going to be like tried to stuff into that thing. It's going to serve the whole hospital from a block away.
Right.
So the problem is that people have had experiences with AI and it's come up short. And then
No, I think most people haven't had experiences with AI in these really production grade environments. And I think we as an industry need to make them production grade.
We need to close the gap.
Yeah. They're just not production grade yet.
Part of that skills.
Yeah. Like I said, I mean, every deal we do today is in many ways a new deal because we have to harden things that nobody's had to harden before. Now I'll give you an example. So we built I think the first production grade outdoor 5G CBRS network in Las Vegas with Dish. Okay, we built that. It was a demonstration, but we built it. There's only like 2 5G 7.2 split radios in the world, and we had one of them. But we had to integrate 20 vendors to make that work. And that shouldn't, maybe the SI has to do that once, but like to ask an end customer to do that, like it's just insane. So I think we're going to get these resellable modules. It's like we'll build Walker in a box, right? And it'll be, look, you set up your plant with these things, and you connect it to Walker in a box. You're going to be already at the 60% point compared to your competitors.
There's not a person on our team who doesn't want that.
Walker in a box.
We're working on that.
I like it. I think it's a great product name.
That would be
Walker in a box.
That would be a very ornery box.
Yeah, right. Well, it would have an off switch though, Walker.
There you go. And in fact, that would probably be much more appealing than the real. Any interesting? Let me say this before I ask that last question. I think the biggest challenge in artificial intelligence is going to be trust. It's the trust in artificial intelligence, whether it's justifiable or not, whether the lack of trust is rational or irrational. For me, I don't even operate in the rational or irrational space. It just is, right? It's just, there is a fundamental lack of trust
isn't that provable? I mean, if I say, look, this can improve your uptime, and I show you it'll improve your uptime, you don't care.
That's exactly it, right?
Yeah.
But you have to say, do you want, the old Steve Jobs adage, do you want this, right? So rather than talking in theoretical terms about what artificial intelligence can do for you, you have to show people what it can do. And the way that we're doing it is we are implementing infrastructures where machine learning and artificial intelligence can plug in natively, so that what we have is an infrastructure that was built on solving a specific problem. But it just so happens that we made architectural choices that makes it seamless in plugging ML, models, training models off of that data, or, plugging artificial intelligence decisions into that data infrastructure. And then we go, do you want this? Right. Or we look at that infrastructure and go, here's what's possible. Do you want this? Right. And I think that's how you overcome it. But I think the biggest challenge is trust. The idea, I mean, just as powerful as OpenAI is, we get a 30 to 30x return on some tasks. Okay. With OpenAI.
Totally. Yeah.
Right. And manufacturers still don't want OpenAI on their plant floor. 30x.
I mean, well, what does on your platform mean? Because if the consequences of it getting wrong are low, then I would say all day long.
Let's
if the consequences are high, keep it off.
Let's say it's something as simple as putting a chat window at a cell where an operator is working, where
describing what's happening.
Right, and the operator can interact and can ask something as simple as, I'm having this problem with this product code. What
that'll change. Like all the hidebound companies that are afraid of this technology, like some of them will die or will go through a lot of pain, and some of them will be early adopters, and the winners will lead the laggards. I mean, the technology adoption curve's the same for everything. Like ATMs, nobody trusted ATMs when they first came out. It took 10 years to get 50% of the U.S. population comfortable using an ATM. And I'm sure it's the same for online commerce. Like nobody trusted it. Well, what changed? It just became more common. And yes, it became more trustworthy. And so I think that's just going to happen. Like, yes, but you're absolutely right, Walker. Like that's our job is like our job is to make somebody in the factory feel comfortable having and showing them like, look, this is air gapped. If that's what they need, right? It's like OpenAI is not getting this data. Let me show you how that works. Or maybe it's not OpenAI. We're using, open source foundation model. One of the Hugging Face models. So who's have to use? Yeah.
Who's better, Gemini or OpenAI?
Claude.
No, you have to choose between the two.
Well, so
Gemini or OpenAI?
Okay, it depends on the task. So I use all three. I use 4, including Perplexity. I use 4
Do you use
every
Grok?
day. No, I do not use Grok. I don't like Grok, and I'll try it again. I didn't like Claude. I don't like Claude when it started, but the new version is really awesome.
Which one is Claude?
Claude is Anthropic.
Yeah.
Okay. So, and they just came out with the Claude 3 Opus, which is pretty badass. But the differences are really small and really subtle. Like I like Gemini because it has a little bit of an attitude, not as much as Grok, but it has a little bit of an attitude. And so,
why would you say you don't like Grok if you haven't used it?
I used it once.
Okay.
And it was kind of smart alecky, and like it didn't seem like it was something I would use for my job.
Got it. Okay.
But Claude didn't when I first tried it either. It wasn't just giving me what I wanted. So I used them all, and I think they're different. I think for many tasks that I was doing, Gemini's better than ChatGPT, than GPT-4. Claude beats both of them, and like I said, I've spent over 1,000 hours at least in LLMs, just learning how to like do this crap. But it's going to change again. Like they'll keep one-upping each other. Like this is really, really interesting. You know what I really like doing? I like having them compete against each other. So, there's adversarial generative networks that they do this kind of on their own, right? You've got 2 agents that are trying to create challenges for each other. So I just do it. I'll have one write an essay and I'll have the other critique it. Then I'll take the critique and the essay, and I'll have the third one rewrite the essay based on the critique. Then I'll take the output of that and I'll have the first one critique it again. And I'm not saying it gets any better, but it's a lot of fun.
No, that's a very useful tool to be able to evaluate an AI.
I have a pre-engineered prompt that I use that I have a model output its answer plus its justification for its answer, and then an instruction as a prompt for the next model, and then I just paste that all in to work them off against one another. The problem is the average user treats LLMs like Google, right?
Oh yeah, well, and that's changing too. Like you should not have to prompt engineer. AI should be way better. You have to be good at describing the output you want. That's what you have to be good at describing, because it's not going to make it up very well. It might come up with a good answer, but it's just luck, or it's pre-training. But if you're very specific about the outcome you want, and then you even help it like identify the likely pathways to get to that outcome, it's really good.
Well, let me ask you this question. Yeah. I'm really surprised on the Grok piece. I didn't know that. What are your thoughts?
Mention it. So once you didn't,
it really. I actually think it is quite incredible.
Okay, I'll try it again. I tried it the first time it came out, and
I haven't tried it yet, but I want to try it. You have to be an X premium subscriber.
I'm quite impressed at the speed of development. I mean, I'm still, my mind is kind of boggled at how quickly they were able to produce something viable. But
Grok's advantage is that it has connected to all the Twitter or X data real time.
Yes. And by the way, that is the event of the public square, right? It's all the events of the public square. But how do you scrub the data for the garbage? Because there's lots of garbage, you know? Let me ask you this real quick, Matt, and then we'll take it home. Because we're long here. But what are your thoughts on Elon in general? How do you view
really? Okay.
Yeah, how do you view Elon in the modern economy and in the economy of the future? Like, how do you view him?
Wow, that's okay. So I've had many emotions. My arc of Elon has gone many places. There are some interviews he's had where I'm just like, this is one of the most profound talks I've ever seen.
Right.
You know, when he talks about solar energy and the future of the Earth and the diminishment of like the absolute fact that we are going to run out of fossil fuel, right? Like it's inevitable, right? And we're not going to run out with the sun. So he's just so elegant sometimes. And then he's just a dick. Like he does stupid stuff. He says stupid things. And I just don't know. I don't know why that is.
Can you give me an example? You gave me an example of something profound, which was his talk about. Can you give me an example of?
Well, like when he called that diver guy a pedophile. Like why? Why would an adult? Like he acts like a 5-year-old sometimes. Like why would you do that? Or he says some things like the whole thing about the Putin and the it's like it's a little too much for me. Like he's really good in his areas of expertise: space flight, autonomous vehicles, electric vehicles, solar panels.
Right.
But in terms of like how to be a human, I think he's just an asshole sometimes.
Well, I don't think you can be Elon if you're purely human.
I do think
maybe right. Oh, I mean, his brilliance is indisputable, and I would like to meet him. I would like to have him at dinner. I would not want to be his enemy, though.
As someone on the autistic spectrum, I can relate to a lot of what he says, and I do think a lot of the people misunderstand him because of that lack of social.
So that is so true. So, as someone in the marketing world who works with a lot of people that are a little autistic.
Right. You have very high EQ. You can pick up on social cues easily. That's
that also, and I think sometimes he just looks like he's tweaking. I'm sure it just looks like he's
he's been sleeping on the factory floor a little bit too much.
You know what I find, Matt? The reason I asked that question was just because of the Grok piece, but I love talking about Elon, and people will ask me like, what are you a fanboy? I'm like, well, no, I'm not a fanboy at all. Like I've been in the room with Elon many times.
I am kind of a fanboy, but I don't want to admit it because like he's just embarrassing sometimes.
But what I find is that people's perception of Elon is generally tied to which part of the value chain you focus on, right? If you're a person who focuses on the output, then I think you're much more likely to be
results.
Yeah, if you're focused on the result, then you are much more likely to hold him in super high regard. If you are focused on the process, like in the middle, then you're going to hate him because he's the guy who's creating pain and you know what I mean. But I think if you're a person who's focused on the brainstorming side, I think you're much more likely, that is the input. You are much more likely to hold him in high regard. It's that middle, the ugly part of the sandwich, I think is uncomfortable for most people. For me,
and his lack of filter.
I actually love that because in this day and age,
I mean, sometimes yes, it's endearing.
I literally just had a meeting with my executive leadership before this podcast. That's why I was 3 minutes late, Matt. And we're getting ready to add 6 engineers. We're hiring 6 more engineers. And I said, I want to sit in on every interview. And the reason I want to sit in on every interview, I won't talk, but I'll just hear. I think we're hiring people who are too nice. And, I sat in on our staff meeting last Friday and I asked a very direct question of my team. Like I wanted critiques. I wanted criticisms of our organization. And I got fucking crickets.
I mean, that's so interesting.
And
because I think of myself as a really nice person, but I speak my mind. I'm pretty direct. Like I think of my senior management teams, I'm direct.
And so I think for me, I like disruption. I dig it. One of the things I like about you, Matt, but you're unique. You're a guy in marketing who openly admits you're a contrarian. Like that, you don't see that in marketing. You don't see marketers saying, I play devil's advocate and I'm a contrarian thinker. Like what you say.
It's the only thing that makes marketing fun.
right?
And it's what makes you good. If it's differentiate. Like the secret of great marketing is differentiation. Secret of great product is differentiation. So
Absolutely.
yeah, contrarian is just another way of saying differentiate aggressively.
All right, well, man, I appreciate you coming on. I appreciate you coming on, man. Thank you for staying over. This was
so much fun. I'm so glad we got this to happen. So I do thinking about this. I actually think there's a project that you and I, you can cut this out if you want later, but I think a project you and I might want to work on. Like I want to do, I don't know, maybe it's a YouTube channel, maybe it's a podcast, maybe demystifying AI. It doesn't exist. I want to do demystifying AI. I really, really want to help the world understand all this just crazy stuff. That's super interesting.
A workshop. Or
you know what would be really cool? And I think we'll leave this in, but here would be a great way. I think that we do a limited release. We do it in 6. Some of my favorite podcasts are not the ones that go on forever and ever and ever. There are
like 6 episodes. We can bring on experts.
Right. 6 episodes.
Let's get Jeff Dean. Let's get Peter Beal. Let's get Andrew Ng. Oh,
and go start to finish. And there's a conclusion, and then you could do updates later. I
love it.
Love it. All right. Awesome. All right, Matt. Appreciate you jumping on, dude. We'll do this again.
Jack Walker, pleasure. See you guys
for watching. Like, subscribe, comment down below, and we'll see you in the next one.